I'm going to explain how to use critical value, z-score, z-critical. Okay, so here is example. We need to find critical value z that is necessary to form a confidence interval at the level of confidence C is equal 0.83. Okay, C is equal, oh, I guess I can write down higher here. Okay, C is equal 0.83. Let's understand what it is. The Z critical that we need to find. So first of all, let's draw our bell-shaped normal distribution. Okay, not bad. So 0.83, let's assume it's this much. And we shade it. Okay. So I need to clean this piece. All right. That's good enough. This is our 0.83, which is 83%. Okay, here we have our z-scores, which is in this case we call it a z-critical, because this is confidence interval is separated from error. Error, those are two tails. Okay. All right. So since we are going to have here negative z critical and positive z critical, and 0.83 is between these two tails. So what I'm going to do, I'm going to find the area probability for this one tail. How I'm going to find it? We know that the entire area is 1, right? 100% or 1. So 1 minus 0.83, it's going to be 0.70, oops, 0.17 or 17%, correct? Okay, now since this 0.17, it's going to be for two tail tests, these two yellow areas, but we need for one, correct? So I'm going to divide 0.17 divide by 2, because I need one tail. 0.17 cover two tails. So if this 100% or 1, this entire area, if I do minus this 0.83, I will get these two yellow areas. To get 1, I have to divide by 2, because these two yellow areas are symmetric. So I'm going to get 0.085. Okay, so this is area. This is probability, so we get 0.085. So from here, what we are going to do, we are going to go to the table. 0.085, we are going to the table, z-score table. Now, 0.085, it's 8.5%, correct? Since 8.5% is less than 50%, therefore, we are going to look in the negative z-score table, correct? So let me see how many zeros. We have 1 0. Therefore, I'm looking in the table of negative z-score. So 0.085 here, 0.0808. Let me see. 7977. Where is it? 85. I guess I can. Let me see if I can find 85. Well, here it is. Zero point 0.085 approximately. Here it is. This one. Let me make it smaller so I can shade it. Here it is, 0.085, which means if I come here, negative 1 free, and if I come here, it's going to be 0.7, so negative 1.37. Okay, so z-score for z critical is going to be positive value of z critical, because we are using positive value. Another example, confidence. Let me see, confidence interval C is equal 0.93. Okay, so just like here, we need to subtract, right, to get two tails. 1 minus 0.93, it's going to be 0.07. And then divide by 2, we get 0.035. So which is less than 50%, which means again, we are going to find it in negative z-score table. Let's go to our negative z-score table. Okay, let me clean this so I won't have mess. All right, so 0.035, let's see, 0.03 here, 359, 0.301, here it is. Okay, 0.035. All right, so from here it's going to be negative 1.8, and here it's going to be .001. Yes? Okay. Here we have negative 1.81, which is positive value, will be 1.81. So Z critical is going to be 1.81. It's not difficult, is it? So you have to be a little bit understanding that it's going to be 0.035. It's a probability, it's area. So you are going to in the body and find Z critical. Okay, let's see what's going to be next one, interesting one. Next we are going to do margin of error. Margin of error. Okay. What is margin of error? That's a maximum value that error can have. Okay? So, what do we have? Find the margin of error for the given value of C. For the given value of C, sigma and n. Okay, this is what we are given. So we are given C is equal 0.9, sigma is equal 2.8, and n, sample size, is equal 81. We need to find margin of error. When we solve problem, we always start the problem solving from the end. So if we need to find margin of error, so first of all, let's see, what is the formula for margin of error? This is the formula. Margin of error is equal Z critical sigma over square root of n, right? So what do we have? We have sigma, we have n. All we need to find out is Z critical, and we already know how to find Z critical, correct? To find Z critical, we are doing 1 minus 0.9, it's going to be 0.1. Dividing by 2, to tell, it's going to be 0.05. Okay, 0.05, it's a negative value, so 0.10 after decimal, yes. Okay, 0.0547. Okay, let me see if we can find 48. This is 0, okay. Yeah. Very easy to get confused. How many zeros? 0.05. Okay, we're going further. Here it is 548. 516. Here, it's gonna be between 0.05 and 0.495. It's right in the middle, right? It's gonna be right here. Right here it's gonna be. All right, so let's see, it's coming here, -1.6, and coming here. Yes, this pink color is going to be our case in between, and it's going to be between 0.04 0.05, which is going to be 0.45. So -1.6. Let me clean this so nobody get confused. Okay, so -1.645. Okay, which means in the positive version it's going to be Z critical is equal 1.645. Z critical, we are taking positive value. Okay, let me move this in the middle so sound is too much on the side. All right, 1.645. Once we have our Z critical, we can find our margin of error. So margin of error is equal 1.645. Here sigma is 2.8, and we have square root of 81. So this is going to be equal E is equal 1.645. Here is 2.8 and divided by 9. So as I mentioned before, you do not round any number during the multiplication. Let me see what I'm getting. 1.645 times 2.8, that is equal 4,606. I mean 4.606. And dividing by 9, I'm getting 0.511 and whole 9 yard. All right, so how we can round it up? I would say till 3 digits, maybe 0.512 if I round it up. Okay, 0.512. Next one, construct the confidence interval for the population mean. Construct confidence interval for the population mean mu. Okay, is given C is equal 0.9. Okay, X bar is equal, that's a mean for the sample. It's equal 15.2. Okay, and then sigma equal 10. And n is equal 45. Okay, so how we gonna solve this? So we need to find the confidence interval for population mu. So population mu interval it's gonna be x minus x bar minus margin of error and x bar plus margin of error. All right, that's a confidence interval. That's what we need to find. Let's see what we have, what we don't have. We have x bar, right? It's right here. What we don't have, it's our margin of error. So margin of error, we already know the formula for margin of error is equal z critical sigma over square root of n. Let's see what we have here. So we have sigma, here it is, 10. We have n, it's given n. So all we need to find z critical. So that means once we have z critical, from z critical we can find margin of error, and once we have margin of error we can find the interval for population mean. Let's do it. So to find z critical, we have c is equal 0.9, so 1 minus 0.9 is equal 0.1. So from here 0.1 divided by 2, it's going to be equal 0.05. Back again, we had here 0.05, right? Here it is. Z is equal, Z critical equal 1.645. Z critical is equal 1.645. And I think the shading is stayed here, 0.05. It's right here. Okay? And it's between 0.505 and 0.495. And that's how we got it. Next. So margin of error from here equal positive 1.645. Sigma is 10 and n is square root 45 because we have here 45. All right, so this is equal 6.45. We multiply by 10, and let me see, square root of 45, it's gonna be 6.70820 rounding 4. All right, so once I divide, I'm going to get 16.45 divided by 6.70820, and I'm getting 2.452. Okay, and my x is 15.2. So from here, once I have margin of error, I'm going to add and subtract our margin of error. Okay, now one thing I want to tell you, so we are going to use x bar and error. Since x bar is given with 1 decimal, so very likely, highly likely, they will need our margin of error also with 1 decimal. So if I round it up, I'm going to get 2.5. So you are looking to the numbers that you are going to use with your value that you just calculated. So from here, margin of error, at the population mean is equal x bar, which is 15.2 minus 2.5 and less than 15.2 plus 2.5. And as a result, you are getting 12 minus 5 is 7, 4 minus 2 is 2, and here is 1. So mu is greater than 12.7 and less than, now let's add 17.7. And this is gonna be our confidence interval. Okay. Next, let's solve another problem like that. So find the minimum. Okay, now we are going to solve sample size. Minimum sample size. Find the minimum sample size n. So n is going to be equal question mark. Sample size n needed to estimate mu for the given values, the confidence interval, sigma, and error. Okay, so we need to find n minimum. Let me make it crystal clear. Let's first of all write down what we have. C is equal 0.95. Oops. Next, sigma is equal 9.2. Margin of error is equal 1. So we need to find n minimum sample size. All right. So as I mentioned, we are starting solving problem backwards. which means, first let's write down the formula for your minimum sample size. N is equal, formula for N is Z critical sigma over margin of error squared. By the way, this formula for N derived from this formula of error. Whoever is at the challenge himself, they can try to find it, how you arrived. Or if you are interested, text me, I will solve it for you. To show you how to derive this N. Okay, so what we have here and what is missing? We have Z critical, no, is missing. We need to find out. Z critical. What else? Sigma we have. Error we have. All we need to find out, Z critical. Well, let's get going because we know how to find Z critical, right? 1 minus 0.95. We are getting 0.05 and divide by 2. It's going to be 0.025. Okay, let's go find 0.025 and it's going to be negative z-score table 0.0222. I guess that's what's going to be 0.025. I don't think I will find anything closer. 0.228. This is 1. Um, 0.25. Oh, here it is. And exactly what we need. Let me double check. One zero and then 2.5. Okay, that's it. So let me clean this. From the previous one, so it won't confuse anybody. Okay, so we have coming here negative 1.5 and coming here 0.06, which is going to be negative 1.96, negative 1.9 and 6. So the critical we always use in a positive format. So it's going to be the critical is going to be equal 1.96. All right, so from here, N is going to be equal, so Z critical 1.96 times sigma, which is 9.2, and dividing by, error is 1, and all this we are squaring. Oh, it's going to be scary to multiply and then square. All right. Let me see what we're going to get. 1.96 times 9.2. Okay. And then square this. It's going to be, the answer is 325.15. Let me see. 325.15, which is approximately, because it's a minimum, so I don't mind to write down, 326. When it's come to minimum sample size, you don't round down, you don't do arithmetical or algebraic rounding. You always round by one number higher because it's a meaningful number, correct? You don't if you have, let's say, you have people. So since you have 325.15, you don't cut one finger and move to the sample, correct? That would be horror. So we always round by one number higher, 326 sample size, and that is a minimum sample size. So with clean conscience, you can round to the one number higher, because if otherwise algebraically, if you would round, you will round to 325. Okay? So I think that's it. Minimum sample size. What else? Oh, let's find sample mean. Let's find sample mean. Another interesting problem here. So, use the confidence interval to find the estimated margin of error. Then find sample mean. Okay, so we have a store manager reports a confidence interval 46.8 and 78. Okay, reporting confidence interval 46.8 and comma 78. Okay, when estimating the mean price in dollar for population of textbook. One more time. So a store manager reports a confidence interval 46.8 up to 78 when estimating mean price for the population textbook. Okay, so we need to find, first we need to find estimated margin of error. So my margin of error, question mark, and then we need to find sample size, sample mean, x bar is equal question mark. Let's see how we're gonna solve this problem. So we know that confidence interval mu is x bar plus error, minus error. I'm saying error and typing margin, typing mu. And less than x plus x bar plus error. Okay. So x bar is our sample mean, and E is the margin of error. The margin of error is equal to half the width of the confidence interval. So we can calculate that way also. So margin of error is equal half the width of confidence interval, which means margin of error, it's gonna be equal. So 78, oops, minus 46.8 and divide by 2. Okay? All right. So this is why we are solving this way, because why we are not applying the formula z critical sigma over square root of n. Because if you paid attention, it's asking find the approximate value. Okay? We are going to use the confidence interval to find the estimated margin of error. So estimated, not precise. And then find the sample mean. Okay? So estimated margin of error is the length of the interval and divide it by 2, which is going to be, okay, let me see, 78 minus 46.8, that is going to be 31.2. And then divided by 2, we are going to get 15.6. So this is our estimated margin of error. And also estimated mean is the middle of the confidence interval. All right? So to find sample mean, we either can add the margin of the error to the left end point. Left end point going to be 46.8. Okay, or we can subtract margin of error from the right end point. Okay, so we can add to the left end point. So it's going to be 46.8 plus 15.6. So this 15 margin of error approximately, let me put this way, approximately. And this is X bar also approximately. So this is going to be 8 plus 6 is 14, 1 in mind. 6 plus 5, 11, and 1, 12, 1 in mind. 5 and 62.4. Okay, so sample mean approximately 62.4. So one more time, you can find approximately sample mean by either adding this margin of error to lowest level, meaning left limit, or subtract from the highest one, margin of error. And here we got approximately margin of error 15.6 and X bar, which is sample mean, it's going to be 62.4. Okay, solving next word problem. Okay, what do we have? It says you are given the sample mean and the population standard deviation. Use the information to construct 90 and 95% confidence interval. So its confidence interval C is equal 90. C1, let's put, because there are two, and then C is equal 95%. Confidence intervals for the population mean. Okay, so we are given, one more time, we are given sample mean and the population standard deviation, where is mean price is $128, sigma is $19.2. So use this information to construct the 90% confidence population confidence interval for the population mean and 95% for the confidence interval for the population mean. All right, let's see how we are going to solve it. So we're going to solve precisely with the way we solved previous problems. So our mu is equal x bar minus error and less than x bar plus error. That's step number 1. Next, step number 2 is going to be, we have x bar, correct? It's 128. What we don't have is margin of error. So margin of error is equal z critical sigma over square root of n. So let's work on it. So to find margin of error, we need to find z critical. Yes? Sigma is given, and sample size also should be given. Hold on, where is sample size? Let me read one more time, I missed somewhere. Random sample of 35 homes. Okay, n is equal 35, here it is. We have it. All right, let's solve it. Actually, I would recommend to put this video on the pause, try solve it on your own, and then turn it back and check it how you did. So I will take and solve for 90%, and I leave it on you to solve for 95%. So for 90%, it's gonna be, it's a 0.9, right? 1 minus 0.9, it's gonna be 0.1. So divide 0.1 by 2 for 2 tails, 0.05. We solve it, this 0.05, we have it, right? Here it is. No, 0.025, but we solve with 0.05. Yeah, here it is, 0.05. We have it. Well, okay, 0.05. Z-score is 1.645. Let me write down. Z-score is 1.645. That's all right. You already know how to find it, right? Okay, 1.645. So from here, margin of error is going to be 1.645 times sigma is 19.2 and divided by square root of 35. All right. So margin of error is going to be 1.645 times 19.2 and square root of 35. It's going to be 5.916. Okay, so let's find the margin of error. That is going to be equal 1.645 times 19.2 and divided by 5.916. And we get 5.3387 and whole 9 yards. Okay. I'm looking here. Sigma, x bar is a whole number. And then sigma using only 1 decimal. Then I'm going to use 1 decimal, most likely. So it's going to be equal 5.3. Margin of error. Okay, so I have x bar and I have margin of error. So mu is going to be, my x bar is 128 minus 5.3 128 plus 5.3. Okay, so 128 minus 5.3, it's going to be 122.7. And if I add them, here will be 133.3. And this is going to be my confidence interval. Okay? So confidence interval, it's going to be, let me write down final answer. If I'm going to plug in, it's going to be 122.7 comma 133.3. Okay, one more, the last one, and we will be done. So, psychologists at a university compared the levels of alcohol consumption of male and female freshman students. Okay? Each student was asked to estimate the amount of alcohol, beer, wine, or liquor they consume in a typical week. Summary statistics for 127 males and 181 female is given. So let me write down. It's given sample size N for male and for female. For male is equal 127, for female 181. Okay, X bar for male it's 16.75. For female is 10.79. Also, standard deviation for male, it's going to be 13.56. For female, it's going to be 11.52. Okay? So, for each gender, find 95% confidence interval for the mean weekly alcohol consumption. I'll find only for one gender, let's say male, and female you can find yourself. I don't think it will be a big deal once you know how to do it, right? So this is for male. I'm going to do for male. Okay? Will I be able to make it thick? Yeah. So it's 13.56, 16.75, and so on. All right. Let's see how we are going to work with it. And the confidence interval is 95%. C is 95%. Okay. Let's start working on it. So, what we're gonna do? Confidence interval, we have to get mu x minus x bar minus margin of error and x bar plus margin of error, which means we're gonna write down mu is greater than x bar minus margin of error is z critical sigma over square root of n, right? And less than x bar plus z critical sigma over square root of n. Okay. So what do we have here? Let's find, we need to find Z critical first of all for 95%. Okay, we have done it, but I'm going to do, let's do this time again. 95%, which is going to be 1 minus 0.95 is equal 0.05. And 0.05 divided by 2, we get 0.025. And to expedite 0.025, where was that? Okay, I'm not going to waste my time looking. 0.025, oh, here it is. 1.96. Okay. Z critical is equal 1.96. All right. So what's gonna happen? Mu is equal x bar. X bar is how much? 16.75 minus 1.96 sigma. Actually, in this case, it's given S, but it doesn't matter because we can use it, even sigma. So it's gonna be times sigma is 13.56 over square root of n. N is 127, right? Right here. So let's see. 127 and square root, it's going to be 11.269. 11.269. Why I'm not going all 6 digits? Because, where is it? Oh, we have 2 digits here, see? 16.75, 10.79, 13.56, 11.52. So I'm going to go 2 digits, which is going to be 27. Otherwise, if it's not given, so then you are going all 6 digits. 2.227. All right. Let me see how much I'm going to get. This is this piece I'm solving, right? This one I'm solving. So 1.96 times 13.56, okay, and divided by 11.27, and that is equal 2.36. So 2.36, so 16.75 minus 2.46, 36. Okay, so 16.75 minus 2.36, that will be 14.39. Okay, and for addition version, what we are going to have? The same way, but adding, right? Let me see. Okay, 16.75 plus 2.36, and that is equal 11.11, 19.11. which means we can say that mu is greater than 14.39 and less than 19.11, which is fitting in the interval 1439 and 19.11. Okay, so we solve it. Confidence interval. So I found confidence interval for male. So you can find for female also precisely the same way. Okie dokie. See you at the next video.